Hey guys, so I'm going to be going through Unit 4, Lesson 6 on limiting reactants and stoichiometry with you. And we're going to start off with problem 8 from this lesson. And we're going to actually do it together. Please get out a piece of paper and take notes and follow along. And if I assign this to you, I might ask you to send me a picture of your notes. I'd appreciate it if you did. But if you're just watching to figure it out, awesome. It'd be great if you wrote it down as well. But this problem in limiting reactant in general is multi-step. So you're going to have to follow along with me as best as you can and then ask questions afterward in my classroom. It's okay to have questions. It's okay to be overwhelmed. Wrestling is a good thing sometimes. And so I want you to try to wrestle with this. And even if like you understand half of it or 70% of it, that's awesome. And then come back to my classroom and tell me what parts you got stuck on. Okay. So the first thing that we need to do when you have a limiting reactant problem is to write out the equation. Okay, hold on, it's asking me to reload this for some reason. Okay, we need to write the equation. And so I'm going to kind of circle important information here. It says that aluminum reacts with sulfuric acid. Okay, actually I'm going to circle the whole thing to produce aluminum sulfate and hydrogen gas. We're going to make a formula out of that. So solid aluminum is just regular aluminum. Solid aluminum. The with means that we do a plus sign. Sulfuric acid, you learned how to name acids in a previous lesson from this unit. But to be honest with you, acids are kind of complicated to name. And if you want to double check online and be like, what's the formula for sulfuric acid? That's fine to do too. The formula is H2SO4, okay? So it reacts with sulfuric acid to produce. Produce means that we draw an arrow. It produces aluminum sulfate. Now we have like this compound. It's aluminum and sulfate merged together, right? So it's gonna be like Al, and then we also need sulfate. We need to look up the charge of aluminum because you have to cross them over. Aluminum right here has a +3 charge based on its location. This ionic charge list you can find in my student resource folder. Aluminum has a +3 charge. Sulfate is a polyatomic ion. You know that it's polyatomic because it ends in 8. And I see it right here. Sulfate is SO4 with a -2 charge. So SO4 with a -2 charge. The charges need to cross over. And so our formula is going to be, I'm going to give myself some space here. I'm going to put parentheses around the SO4. You should always do that with polyatomic ions. And this was -2. The charges are going to cross over. That 2 is going to go here, and that 3 is going to go here. They cross over and around, okay? And if you have any questions on that, just let me know. You can also look up what is the formula of aluminum sulfate, and it will tell you this. And so we do a plus sign. Hydrogen gas. Hydrogen is one of the diatomic elements. You can remember from the acronym, have no fear of ice, cold, root beer for BR. All of these guys are doubled when they are by themselves. Okay, so you just have to know that those gases, whenever they're alone, are diatomic or doubled. Now we have our formula and we need to balance it. I see that there are 2 aluminums here, right? And there's only 1 aluminum over here. So I'm going to put, I'll go ahead and do it. I'm going to put a 2 in front right here so that now I have 2 aluminums and 2 aluminums. I see that I have 3 copies of sulfate in general, 3 copies of SO4. On this side, I really only have like 1 set of it, right? Like SO4. So I'm going to put a 3 in front because I know like when that multiplies out, now I've got 3 sulfurs here, right? Same here. I've got 3 sulfurs. 3 times 1 is 3. I know that I have 12 oxygens here, 3 times 4. And 12 oxygens, 3 times 4. And then now I need to balance my H's. I have 6 H's here. So I'm going to put a 3 right here so that now I have 6 H's on this side. So this is my balanced equation, which is one of the questions that they ask. So choose the answer that has this as the option. So here is the balanced equation, okay? Now it asks us to find the molar masses of each substance, okay? So to find the molar masses, remember, we just look it up on the periodic table and add them together if we need to. So the molar mass of aluminum, you don't have to add anything at all. It's just going to be aluminum. So we just have to find it. Its molar mass is 26.982. I don't know if they ask you to round it or not. So 26.982, it should be close to that. It might be 27 or 26.98 or something close to that. Whatever number is closest to 26.982, okay? For H2SO4, we need to add all of that up. So remember that we have 2 H's there, 1 S, and 4 oxygens. See, H2SO4. So whatever the molar masses are, we need to multiply by that amount. So we're going to go find H, S, and O. H's molar mass over here, let's just make that 1. It's 1.008. So let's just make that 1. S's molar mass is about 32 or 32.1. And then O is about 16. Okay, so I'm just going to do 1, 32, and then 16 to make it easier. So 2 times 1 is 2. This is just 32. And then 16 times 4, if I remember correctly, should be 64. And we're going to add all of that up. So 32 plus 64 plus 2 is 98. 98 grams per mole. Once you learn how to do this, you can double check your work by looking up online what is the molar mass of H2SO4. And Google will tell you. So if you look up what is the molar mass of H2SO4, you can find the answer. The reason I'm telling you this is not because I'm trying to, it's not like it's cheating to me, because there are so many steps to this that you knowing how to ask the right questions is completely fine to me. Getting the final answer from somebody else, that's cheating. But being able to step by step check your work and save yourself some time, completely fine. So this was 98. I'm going to clear my work here just because we're doing the next one now. So this is 98. Okay, and then Al2SO43. Okay, we're going to do this one now. Aluminum is still, there's 2 of them, right? And it was 26.982. I'm going to round that though because I'm lazy to 27. S, there are 3 S's here because 3 times 1 makes 3. And there are 12 O's. So there are 3 and then 12. Sulfur earlier we said, wasn't it 32? They said it was 32. And oxygen is still 16. You just have to look those up on the periodic table. So 27 times 2 is 54. This is going to be 96. 16 times 12, this is going to be a big number, is 192. So we're going to add all of those up and get 342 grams per mole. This is the molar mass of aluminum sulfate. And you can also look that up online to save time in the future. Okay, now we have to find the limiting reactant. What we have to do in this scenario, first of all, is get the balanced equation. So I'm going to move that over. Okay, so I've copied the balanced equation over. To determine the limiting reactant, you have to do a few steps here. You have to identify what you're starting with. And so looking here, we need to kind of read this problem a little bit more in depth here. So it looks like we started with 107.9 grams of aluminum and 637.5 grams of sulfuric acid. So I'm going to write those numbers down. We started off with 107.9 grams of aluminum and then 637.5 grams of sulfuric acid. So write down the gram amounts of the starting reactants. So see how these are our reactants right here? So we're going to write that down. We are going to convert them all the way over to grams of aluminum sulfate for both of them. This is how you determine the limiting reactant. Okay, so we're going to see how many grams this much aluminum would yield, how many grams of aluminum sulfate it would yield. The first step is to convert it to moles. So I'm going to put moles of aluminum on top and grams of aluminum on bottom. Now we need to put in the molar mass, which earlier we said was 26 or like 27 grams. Remember from this step, we said it was about 27 grams. The grams are going to cancel out. Now we're going to convert it to the moles of the product that we want. The product that it is asking us about in the situation is the Al2SO4 okay? So that is what's going to go on top. And what needs to go on bottom is what we want to cancel out. And you see, we want the moles of Al to cancel out. Moles of Al, like that. We need now the mole to mole ratio. This is not molar mass anymore. Molar mass is how many grams are in a mole. This is called a mole to mole ratio. We always get this step from the coefficients in the equation. Okay. So with the Al, you see how there's a number 2 right here? So we're going to put the 2 with it right here. Okay. With the Al2SO4, there is no coefficient. There is no number, which means that it's just an invisible 1. So basically, we figured out, okay, for every 1 set of this, we have 2 sets of this, right? For every 1 of that, we have 2 of the other. So you get that from the equation. And last step, we convert the moles to grams. We want grams. And it's the aluminum sulfate. So we need to put in the molar mass of the aluminum sulfate, which we got right here as 342. See, that's the aluminum sulfate right here. That is the molar mass of the aluminum sulfate. So the 342 is going to go on top now because we want grams to be on top. And the 1 mole is going to be on bottom because we want that mole to cancel out. You are allowed to flip it depending on what you're trying to get to. So we're still doing molar mass. Like this is molar mass of aluminum sulfate. This is molar mass of aluminum. But in this situation, we're going to have it on top. And now we need to calculate this. It helps if you use a scientific calculator like the Desmos scientific calculator. You can multiply everything on top and then divide it by the multiple of everything on bottom. It's really whatever works for you. So I'm going to plug that in times, and I want you to try to do it too. Or if you feel like you're stuck, then just let me know. And I'm getting 683.4 whenever I do that. So I'm going to write that down over here that this is 683.4 grams of 683.4 grams of Al2SO4. So we did that for the aluminum. Now we have to do it for the H2SO4. And I'll kind of explain everything in a minute. So I'll do a different color this time to kind of make things different. So again, we need to go all the way over. So we need moles of H2SO4 to be on top and grams of H2SO4 to be on bottom so that they cancel out like this. If you notice, it's the same as up there, except now we're starting with H2SO4. The molar mass of H2SO4 that we added up earlier is 98. So 98 grams for every 1 mole. And now we need to get to moles of Al2SO4. And we want the moles of H2SO4 to go away. Okay, so that it goes away right here. And again, this is a mole to mole step. We need to look at the equation here. So for the H2SO4, there's a 3 in front of it. So I'm going to put a 3 on the bottom. And again, for the Al2SO4, there's nothing there, so it's just a 1. And so we're going to put a 1 there. And so now I have the last step, which is the molar mass. We're trying to get to grams of Al2SO4. And we want the mole to go away. So again, the molar mass is still 342 there for every 1 mole. The molar mass was different down here because we were doing H2SO4, but we're still converting it to the same product, which means that we have the same molar mass of aluminum sulfate on top. So now I'm going to calculate this. And I get 741.6. So that's going to be my answer here. Okay, so why did we do all of that? What does this even mean? Like, what was all this work? What we figured out was that if you have this much aluminum, you should be able to make this much of your product according to that recipe, that equation. If you have this many grams of sulfuric acid, you should be able to make this much aluminum sulfate according to that recipe. So the limiting reactant is whichever one produces the least amount of your product. That is what limits you, okay? So which one produced the lowest product? Well, this is our lowest product, so the aluminum did. So aluminum is our limiting reactant. Aluminum is our limiting reactant because it only was able to produce this much compared to the other one. To find the theoretical yield is whatever the yield is from your limiting reactant. So this, what I'm circling here, is our theoretical yield. So our theoretical yield, I'll write it down over here. Theoretical yield is just whatever the yield was that we just calculated. 683.4. That's theoretically how much aluminum sulfate we should get. Al2SO43, yep. Okay. And then the percent yield, I think they also ask for that. Let's look at that. They ask for the percent yield as well. The percentage yield is like in the problem here, it says that it produced 581.7 grams of aluminum sulfate. So I'm going to write that down. 581.7 grams of aluminum sulfate were actually produced. That's like the actual yield. The actual yield. So the problem always gives you the actual yield. The percent yield is the actual yield divided by the theoretical times 100. So it is 581.7 divided by 683.4 times 100% to get your actual yield. So 581.7 divided by 683.4 times 100, and that is 85.1%. Okay. So the percent yield is just the actual yield, which is given in the problem, divided by what you theoretically got. And the theoretical yield is whichever one was produced from the limiting reactant. We figured out the limiting reactant was aluminum. It's either aluminum or sulfuric acid. And we figured out it was aluminum because it produced the lowest amount of that substance. And generally the trend is you start off with your grams of your reactant, you convert it to moles, and then you convert it to your moles of product. That's what we did. And then you convert it to grams of product. Okay. That was kind of the step-by-step guide that we did. If you are stuck or overwhelmed, which it's okay. Like I expect that a lot of students will still have some questions, and that's totally okay. I'd like you to come to my classroom and we can work through the next problem together if you need help or have specific questions. But I want you to try to set it up by following my video while you do it. Have a great day.